Hi class, I'm going to work a few examples from section 9.2. This is WebAssign homework called Simplifying and Rationalizing Denominators. The first question says simplify the radical expression. The way I taught this to you in class is to make a factor tree, and then once you have made the factor tree and you have the list of prime factors, circle every pairs of numbers and then we'll move those to the outside. Let me go ahead and just work an example for you. So if we take the number 24, that can be split down to 8 and 3. We can split the 8 down to 2 and 4, and then the 4 to 2 and 2. That 3 from the original 8 times 3 goes all the way down to the bottom. So from this list of numbers, 2 times 2 times 2 times 3, because this is a square root, the index number is 2. That's what I want you to circle. I want you to circle groups of 2, not the number 2 per se, but just matching 2s, like if it was a twin. In class, I probably told you a crazy prison breakout story, which if I didn't tell your class, just let me know and I can tell you the story, but I won't take the time on this video to. There are two 2s right here that makes a pair. To represent that pair of 2s, we're going to write the 2 one time on the outside of the radical. The numbers that did not have a pair, we'll multiply those back together and put that answer under the radical. So we'll put 2 times 3 is 6, goes under the radical. The pair of 2s, we have one pair of 2s, and so 1, 2 goes to the outside, and that's your final answer. Okay, let's try that again, except this time the index number is a 3. Same thing, we'll make a factor tree of 56. So remember, this time you're looking for groups of 3. You're looking for triplets. We have a group of 2 again. So that 2 goes to the outside. You're only going to write the 2 one time because you only have one group of 2s. Any numbers that don't have groups of 3 goes back on the inside. And then you do need to put back your index number of a 3. And that's your final answer. Okay, let's try that again with the index number of a 3. This will be negative 128. What I want you to do when it's a negative, I want you to make the factor tree as if the negative wasn't there. I don't want it to complicate your factor tree. We'll just take this negative and it will be part of the outside of the radical. So if that helps you, you can just go ahead and remove the negative and bring it to the outside of the radical. Okay, here's what your factor tree will look like. In the red box is the prime factorization. You have 7 2s. The index number is 3, so we're looking for groups of 3. Here's a set of 3. Here's a set of 3. Now we have 2 sets of triplets. And so now we're going to put a 2 times 2 on the outside of the radical. Well, we know 2 times 2 is 4, so a better way to write that is negative 4. Remember, the negative came from the original problem was negative 128. We just brought the negative sign to the outside. Cubed root of 2, because there was one 2 left over that didn't make it into a triplet group. And so negative 4 cubed roots of 2 is your final answer. Okay, next I want to show you that we can also simplify expressions with variables. There is an additional instruction that says use absolute value signs if appropriate. I didn't teach you with using absolute value signs, so I did not select any of those problems from WebAssign, but I can't change the instructions, so the instructions will be there, but I want you just to disregard those instructions. Okay, so the best way to do this, I like to just list out how many variables I have. The exponent is the quantity of the variables. So we have 9 A's and 4 B's under the radical. The index number is 2, so we'll be circling groups of 2. We have 4 pairs of the letter A. Here's how we're going to represent that. On the outside of the radical, I want you to write that letter A and then an exponent of a 4, which represents the 4 pairs of A's that we had. And then we have 2 pairs of B's, so we'll write the letter B with an exponent of a 2. There was a single A left over, so that single A goes back inside of the radical, and this is your final answer. Okay, this one is a cubed root of 125A to the 4th, so 125A to the 4th. I'll make a factor tree. Okay, and here's your factor tree. There's 3 5s and 4 A's. Here is one group of 3 5s and one group of 3 A's. The outside of the radical will have 5 times A, which you can just write 5A, cubed roots of A, which is that single A left over that stays under the radical. And that's your final answer. Okay, we're going to switch gears now from simplifying radicals to working with fractions. There's a concept called rationalizing the denominator, which we've talked about in class, or Hopefully you've seen a few videos. The key to rationalizing the denominator, it means your final answer, there cannot be a radical symbol in the denominator. So right now, it's a big radical over the fraction 1/3. A big radical means that there's two smaller radicals, the square root of 1 over the square root of 3. And right here, that square root of 3, that's the problem. We can't leave the answer as is with the radical in the bottom, so we're going to go through a process of changing that number to a rational number so that we can take the square root of it and get rid of the radical symbol. That process is multiplying by another fraction, and we have to multiply by a radical. We want to multiply 3 times a number so that it equals a perfect square number. The easiest way to multiply 3 times a number to guarantee it's a perfect square number is to multiply it times itself, because we know 3 times 3 is 9, and 9 is a perfect square number. Well, just like everything else in algebra, because we multiplied square root of 3 to the denominator, we also need to multiply square root of 3 to the numerator. Square root of 1 times square root of 3 is square root of 3. One more step. We're going to keep the square root of 3, but now I want you to take the square root of the denominator, which will be the whole number 3, and that's your final answer. What we have done is we have taken a fraction that had a radical in the denominator and we rewrote it so that there's no radical sign in the denominator. Okay, let's try that again, except this time we're working with a cubed root in the denominator. So we have the fraction 3 over the cubed root of 25. All right, so let's think about this. The cubed root of 25, if we were to make a quick factor tree of 25, it would be 5 times 5. Okay, next. If we multiply it, we have to multiply it by another cubed root over a cubed root. But we want the same thing to happen as the previous problem, except we want to multiply 5 times one other number, so it produces a perfect cubed number. So right now there's 5 times 5. If we multiplied by one more 5, we would then have 3 5s, and that's a perfect cube number. So that's what we'll do, multiply the numerator and denominator by the cubed root of 5. The numerator will be 3 times the cubed root of 5 over the cubed root of 125. Your final answer will look like this, 3 cubed roots of 5 over 5. Okay, that's all for this video. Please let me know if you have any questions on this homework assignment.